This is Bob Capetta from the College of the Florida Keys, and this is a continuation of the Intermediate Algebra Final Exam Review, starting with number 19, which is the following. We're going to add two algebraic fractions. 2 over a squared plus 4a plus 3 plus 1 over a plus 3. Now we will write this vertically, but I'm going to need to factor a squared plus 4a plus 3. So let me do that first. A squared here, 3 here, 4a there. So a times a plus 3 times plus 1 plus 3a and plus 1a is 4a. So a plus 3a plus 1. So we're going to write this vertically. 2 over a plus 3a plus 1 plus 1 over a plus 3. We need to get a common denominator, which will be a plus 3a plus 1. Bring the 2 and the 1 over, and then look for what's new. So you'll notice here everything was there before. A plus 3 was there before. A plus 1 is there before. Nothing was new. Here a plus 3 was there before. A plus 1 is new. So I need to put an a plus 1 on top. Whatever is new on the bottom has to also go on the top. So now I have 2 over a plus 3a plus 1. 1 times a plus 1 is a plus 1 over a plus 3a plus 1. So I have successfully rewritten this as a sum of two fractions with a common denominator. So what is that going to look like now? 2 over a plus 3a plus 1 plus, focus on the sign, a plus 1 over a plus 3a plus 1, which is 2 plus a plus 1 over a plus 3a plus 1. But 2 plus a plus 1 is a plus 3 over a plus 3a plus 1. And then you'll notice the a plus 3's cancel. So a plus 3 divided by a plus 3 is 1 over 1. They divide out. That sideways green line is really a 1, so what's upstairs is a 1, and what is downstairs is 1 times a plus 1. 1 over a plus 1 is our final answer for question number 19. All right, our next one, number 20, is a complex fraction, so that can get kind of challenging. Let's take a look at number 20. We have 5 over y minus 3 5 over y minus 3 minus 2 over y, all divided by 1 over y plus 2 over y plus 3, y minus 3. So if I'm doing this, I break it up into two problems, the top and the bottom, and then eventually I will divide those two. So what is the top? The top is 5 over y minus 3 minus 2 over y. Common denominator is y times y minus 3. 5 and 2 were there before. What's new? Y minus 3 was there before. Y is new. Multiply the top by y. Y was there before. Y minus 3 is new. Multiply the top by y minus 3. So now I get 5y over y times y minus 3. On the bottom, I get 2y minus 6 over y times y minus 3. But we have to subtract these two guys. So to finish the top, I've got to take 5y minus 2y minus 6 all over the common denominator of y times y minus 3, which is what? 5y minus 2y. So we need to distribute that negative sign. Plus a negative, distribute the negative, distribute the negative. So I get 5y plus negative 2y plus 6 over y times y minus 3. And the result, 5y minus 2y, is 3y plus 6 over y times y minus 3. And we actually could factor that to take 3 times y plus 2 over y times y minus 3. So all of that is the top. And eventually we're going to take top divided by bottom. So let's emphasize that is the top. Now I'd like to do the bottom next, which is 1 over y plus 2 over y minus 3. And my common denominator again is y times y minus 3. Y times y minus 3. Y times y minus 3. The 1 and the 2 are still there. What's new? The y was there before, so y minus 3 is new, so y minus 3 goes on top. The y minus 3 was there before, so the y is new, so the y goes on top. 1 times y minus 3 is y minus 3 over y times y minus 3. 2 times y is 2y over y times y minus 3. So now we're going to add these two together. So y minus 3 plus 2y over y times y minus 3, which is y plus 2y minus 3 over y times y minus 3. And that actually can be factored. That is y plus 3 times y minus 1 plus 3y minus 1 plus 2y minus 3 over y times y minus 3. And that's the bottom. So we did the top here, we did the bottom here. They came from this. This piece was the top, 5 over y minus 3 minus 2 over y. This piece, 1 over y plus 2 over y minus 3, was the bottom. And now we have the top part here divided by the bottom. So that's my next move, top divided by bottom. Top, 3 times y plus 2 over y times y minus 3 divided by the bottom, y plus 3, y plus 1, y plus 3, y minus 1 over y minus 3. Invert and multiply. If we're going to divide fractions, change it to multiplication and flip. 3 times y plus 2 over y times y minus 3 times y times y minus 3 over y plus 3, y minus 1. And in essence, it's one big fraction. 3 times y plus 2 times y minus 3, y times y minus 3, y plus 3, y minus 1. And what divides out? What divides out here? Y divided by y becomes 1 over 1. Y minus 3 over y minus 3 becomes 1 over 1. And we get 3 times y plus 2 over y plus 3 times y minus 1. And that's good enough for me for a final answer. But you certainly could multiply it out if you would prefer to do it in that manner. Well, that was a challenging problem. Our next example is a cube root, number 21. We have cube root of 40. So how do we do that? Cube root of 40. Well, I believe in factoring completely. 40 is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. So the cube root of 40 is the cube root of 2 times 2 times 2 times 5. A cube root needs 3 identical things to be extracted, and I have 3 identical 2's. So that comes out of the cube root, and we get 2 times the cube root of 5 for number 21. Number 22 is a similar question, but it's a square root. Square root of 18b to the 5th. We're going to assume that b is positive, just so that we'll make sure that we have real solutions. Well, what is 18? 18 is 6 times 3. 6 is 2 times 3. 2 times 3 times 3. So 18 is 2 times 3 times 3. b to the 5th. b, 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 b. Now this is a square root. So I need two identical things to be extracted. A pair of 3's, a pair of b's, and a pair of b's. So a 3 comes out, one b comes out, another b comes out. What's left under the square root? Square root of 2b, so we get 3bb, 3b squared times the square root of 2b is my final answer for number 22. Next we have 23, which will require us to solve an equation with algebraic fractions. That will be challenging. So let's take a look at it. 23, and I'm going to start writing it vertically. 23, we have 3y over 3y minus 6 plus 8 over y squared minus 4 equals 2y over 2y plus 4. And our goal is to get a common denominator. So I have to factor everything. The 3y, the 8, and the 2y stay there. 3 times y minus 6 is 3 times quantity y minus 2. Y squared minus 4, you could use the factor box and get y minus 2, y plus 2. And then 2 times y plus 4 is 2 times y plus 2. So now we need to build a common denominator. Let's look at all of the pieces that we have. I see a2 and I see a3. So both a2 and a 3 have to be in the common denominator. What else do I see? I see y minus 2 and I see y plus 2. So what are the most y minus 2's I ever see? I see one of them here, I see one of them there. The most y minus 2's in any one place is 1. Y minus 2 shows up once. What are the most y plus 2's I see in any one place? Just 1, y plus 2. So we've built the common denominator. Now we've got to build equivalent fractions. So I started with 3y and 8 and 2y. So what is new? What is old? What is new? Let's see. 3 was there before, y minus 2 was there before. So 2 is new, and y plus 2 is new. Times 2 times y plus 2, those are the new pieces. Y minus 2 was there before, y plus 2 was there before. So 2 times 3 are new, 2 times 3 are new. Before 2 was there before, y plus 2 was there before, which makes 3 and y minus 2 new, times 3 times y minus 2. Okay. Let's multiply all of this, and what do we get? 6y times y is 6y squared plus 2 times 3y. 6y times 2 is 12y over all of this common denominator stuff, which is 6 y minus 2, y plus 2, plus, let's remember we have a plus sign there. 8 times 2 times 3, 8 times 2 times 3 is 48, over 6 times y minus 2, y plus 2, and then what do we have here? 3 times 2y, 6y again, 6y times y is 6y squared, minus 6y times 2 is 12y over 6 times y minus 2 times y plus 2. Rough problem. This fraction plus this fraction equals this fraction. So let's write all that down. 6y squared plus 12y over all of this stuff. Plus 48 over all of this stuff equals this over all of this stuff. Now just remember, we cannot divide by 0, so I better not get an answer of 2 or negative 2, because 2 or negative 2 makes the bottom 0, and that's not going to be acceptable. Division by 0 leads to all kinds of problems. So now this piece plus this piece equals that piece, so this numerator plus this numerator equals that numerator. So where are we? 6y squared plus 12y plus 48 equals 6y squared minus 12y. In a sense, what we did is we multiplied both sides by the common denominator. So let's go ahead and subtract 6y squared from both sides. And let's go ahead and subtract 12y from both sides. So what does that leave me? Where are we now? That's gone, that's gone. I am at 48. That's 0. Negative 12y is negative 24y. So if I divide both sides by negative 24, it looks like I'm going to say y equals negative 2, but what do I think about that? Notice if y equals negative 2, that makes the bottom 0. If y equals negative 2, this bottom is 0. If y equals negative 2, that bottom is 0. Y cannot be negative 2. Negative 2 is not in the domain. Therefore, we say no solution. Empty set. Our answer of negative 2 cannot work for us in that problem. All right, that will conclude this lesson.